So for this first problem here, we have a limit problem where we need to evaluate a function. That function being e to the 2x minus e to the negative 2x all over e to the 2x plus e to the negative 2x as x approaches 0. And this looks like a pretty horrible thing to evaluate the limit for, but we can do a little bit of simplifying. So with really rough looking limits like this, a thing or method you can kind of go to if all else fails is dividing both the numerator and the denominator by by the leading term. So the leading term in this case would be e to the 2x, and they're both the same in the numerator and denominator. So you divide both the numerator and denominator by e to the 2x. So what that would look like would be something like 1 over e to the 2x times e to the 2x, e to the 2x minus e to the negative 2x over 1 over e to the 2x times e to the 2x plus e to the negative 2x. Okay. And you understand that this is just dividing these terms over here by e to the 2x, or this, what's it called? I don't know, it doesn't matter. So we can simplify this by just canceling out e to the 2x and making it 1. So let's do that really quick. So we're gonna have 1 minus, let's write that down here. We're gonna have 1 minus e to the negative 2x over e to the 2x over, this also cancels out, it's the same thing, 1 plus e to the negative 2x over e to the 2x. Okay, now from here, we can do a cool thing with exponents. So we remember that if we have something like 1 over x squared, it'll be equivalent to x negative 2, since you're just taking this negative means to take the reciprocal of x. So in this case, we're going to apply it to this right here. So 1 over e to the 2x is also the same thing as e to the negative 2x, because you're just taking the reciprocal of x. You're swapping the numerator and the denominator. Okay. So we can write this as 1 minus e to the negative 2x times e to the negative 2x. E to the negative 2x on both the top and bottom. To the negative 2x, e to the negative 2x. And from here, we can just add the exponents since we're multiplying both, we're multiplying like terms, right? Or I guess it doesn't matter, that's like terms, but I don't know. We're multiplying terms that have an exponent, which means we can just add the exponents. So that would be equal to 1 minus e to the negative 4x, yes, minus 2 plus minus 2 equals negative 4, 1 plus e to the negative 4x. Now, let's remember that we are taking the limit of this. So this equation is actually limit as x approaches 0 of 1 minus e to the negative 4x over 1 plus e to the negative 4x. And let's just lock in on this e to the 4x right here. E to the negative 4x. So we have e to the negative 4x, and we're taking the limit of that as x approaches 0. Now, if we just do basic substitution here, this is going to be e to the negative 4 times 0 equals e to the 0 equals 1. And let me double check Desmos really quick. Oh, that is completely my bad. I wrote down the limit equation wrong. This is actually approaching infinity. My bad. So let me rewrite that here. Infinity, infinity, infinity. Okay. Yeah, I thought I went wrong somewhere. Okay. Now this is something important to note. Whenever you have, because this is also just equal to 1 over e to the 4x, right? Whenever you have an x variable in the bottom, and you're solving for when that variable approaches infinity, this will always equal 0. I think you discussed it with Diego before, but just as like a refresher, it's going to equal 0. Like if you have 1 over x as x approaches infinity, it's going to be 0. 1 over x squared as x approaches infinity, it's going to be 0. Because the value just becomes like so incredibly small, it's essentially 0. It's negligible. Okay, so we know that this is equal to 0. And with that in mind, we now have this is going to equal 1 minus 0 over 1 plus 0, and that of course will just equal 1.